Introduction to Java, a computer programming language. What is Java? Java is a computer programming language which is used to interact with computer. What is a computer program? A computer program is a set of instructions to perform a specific task by a computer. What tasks are generally performed by a computer? A computer can perform n number of tasks. For example, a computer can also perform arithmetic operations like addition, subtraction, and division. A computer can understand only machine code, zeros and ones. Machine code, binary code, low-level language all are refers to same. So, how can we write a machine code now? Actually, we don't need to write machine code. Instead, we have to write high-level language, which is readable language, which we can understand by reading itself. Then, how can a computer understand high-level language? Computer don't even cares about high-level language because compiler do that work to computer. Then, what is compiler? Compiler is a software that converts high-level language to low-level language, zeros and ones. By seeing this flow chart, we can get good clarity on code flow. Initially, the source code is saved in .java extension file. Then it enters into the compiler. After compilation, it becomes bytecode, which is saved in .class extension file. Java is platform-independent language. Why Java is platform-independent computer programming language? Java uses JVM, Java Virtual Machine, to run its bytecode, and JVM is present in every computer. What is bytecode? Bytecode is an intermediate code generated by compiler by compiling source code, which is high-level language, while machine code is the final code, which is CPU process. Why other computer programming languages are not platform-independent and why Java is. For example, let's take C language. If we run C code in Windows laptop, it generates Windows executable file. In Linux, it generates Linux executable file. We can't run Linux executable file in Windows and vice versa. Meanwhile, Java compiler generates .class file. So, we can run it irrespective of platform wherever JVM is present. So, that's why C language is platform-dependent language. C and C++ are good examples for platform-dependent languages. By seeing this page, you will get good understanding on platform dependence and platform independence. Here the C code in .c extension file enters into the Windows compiler. After compilation, it gives Windows executable file, which is executable only in Windows operating system. Same like this when C code enters into Linux compiler, it gives Linux executable file, which is executable only in Linux operating system. But when a Java code in .java extension file enters to the Java compiler, it gives Java bytecode in .class extension file. Unlike other compilers, which gives respective executable files, which can run only in their respective operating systems. We can run that .class file in JVM to get output. JVM is not dedicated to any specific operating system. It's present in every OS. Understanding JDK, Java Development Kit Architecture. JDK is a tool which we install to run Java. Here JVM, Java Virtual Machine, is subset of JRE, a Java Runtime Environment, and JRE is subset of JDK. So, here JDK is whole kit and it consists JRE and JVM. Initially, the source code uses JDK development tools like Java, Java-C, Java-P, etc. to develop the code. Here the code is in .java extension file. And it uses Java-C to compile the source code and gives bytecode in .class extension file. And that .class extension file enters to the JRE. And here JRE creates the runtime environment to run the code in JVM by using JRE tools like JavaCPL and JavaFX, etc. And JVM executes the code with the help of class loaders, JVM memory, execution engine, and native method libraries and interfaces. In summary, JDK contains development tools which are used to develop the code. JRE contains runtime environment tools which is used while running the code. JVM contains class loaders used to load the classes in the code. JVM memory creates memory for methods and objects in the code. Execution engine executes the code. Native method interface is a framework in Java that allows users to run the Java code and operate with the applications and libraries written in other languages, example C, C++, etc. It acts as a bridge between the Java platform and native environment, application, or libraries. Native method libraries are libraries that are written in other programming languages such as C, C++, and assembly. These libraries can be loaded through native method interfaces. By seeing this image, you will get clear clarity about the flow of the Java code. Initially, the Java source code enters to the JDK to develop the code by using JDK tools after it compiles the code and give bytecode. That bytecode enters to the JVM to give output. While it executing in the JVM, JRE creates a runtime environment to run the code by using JRE tools. Java is an object-oriented language. Java uses mostly classes and objects in its code. That's why it is object-oriented language. Benefits of object-oriented programming language. Code reusability. We can use the code again and again without creating class for every object. Privacy of data in classes. We can make data private in the class to ensure it is safe. No members outside of the class access the data. And maintainability. It is also considerable benefit of object-oriented programming language. When a class has an issue, we just replace that class with proper class which has no issues. And it reflects in every object of its class, rather than changing the data in every object.